start with the equation x squared plus 4 equals 0. To solve this equation, let's first isolate x squared. We'll subtract 4 from both sides of the equation. Now, to isolate x, we need to take the square root of both sides. Remember, when we take the square root, we need the plus or minus symbol because the square root can be positive or negative. Here's where it gets interesting. We're trying to take the square root of a negative number. In the real number system, this isn't possible. This is where we need to introduce the imaginary unit I, where I is defined as the square root of -1. Let's use this to simplify our expression. We can rewrite -4 as 4 times -1, and then as 4 times I squared. Let's visualize what these solutions mean on the complex plane. The complex plane has a real axis and an imaginary axis. Our solutions are at +2i and -2i on the imaginary axis. To verify our solution, let's plug these values back into the original equation. When we substitute x equals plus or minus 2i, the I squared becomes -1, and we can see that the equation is satisfied. In conclusion, we've found that the solutions to x squared plus 4 equals 0 are x equals plus or minus 2i. These are complex numbers because they involve the imaginary unit I. This example shows us that when we have a quadratic equation where we need to take the square root of a negative number, the solutions will be complex numbers. This is why these types of equations don't have any real number solutions.